In this video, we're solving problem 3.2.8 from the Essentials of Statistics text, 6th edition by Mario Triola. This is what the problem statement says. It says, listed below are prices in dollars for one night at different hotels in a certain region. Find the range, the variance, and standard deviation for the given sample data, include appropriate units, and the results. How useful are the measures of variation for someone searching for a room? Okay, so I'm going to show you how to do this by hand as well as with Excel. So let's start with the range. We're asked to find the range of sample data. So I'm going to stop sharing my screen with you and start sharing my document camera with you. Okay. So here are our values. Rather than listing them in a row, I listed them in a column. That's my preference. Now the range is given by this formula. It's just the maximum value on your list minus the minimum value on your list. So the maximum hotel price is $247. Oops. And then we're subtracting the minimum hotel price of $95. And so the range is this 247 minus 95, which is $152. So there's a price difference of $152 from the lowest priced hotel locally in this certain region and the highest priced hotel locally, at least in the sample that was selected. Okay, so we found the range. Let's see if MyLab Statistics likes our answer. So it's 152, and the units are dollars. It says round to 1 decimal place is needed. We don't really need this, but just in case, I'm going to write it out to 1 decimal place. Okay, great. And then the next thing it asks us for is this sample or the standard deviation. So I will stop sharing my screen with you and we'll work out the sample standard deviation. Now, during your exam over this material, you'll have access to this formulas and tables sheet. It comes with your textbook. And at the top, you'll see the chapter and then the associated formulas. I'm looking for chapter 3, which is about descriptive statistics. And we're looking for sample standard deviation. So I've got sample standard deviation here, and I've got another one here. And even though this formula looks simpler, as we discussed in our videos over this material, in practice, this one's actually much simpler to evaluate. So I'm going to use the second one, which is simpler to evaluate, but more complicated looking. And so I'm just going to write down that formula from my sheet. It's S equals the square root of the sample size times the sum of the x's squared minus the sum of the x's squared, all divided by the sample size times 1 less than the sample size. That's the sample standard deviation. And notice the difference between this and this. With this, you're supposed to add up all of the x values first and then square it. With this, you're actually supposed to square the x's first and then add them. So there's an order of operations implied here, and it's really important that we distinguish between the two. Now, in order to find everything that I need for my formula here, I need to find those x's squared. So I've got my x's here in this column. So I want to square them now. And I'll just use a calculator for that. I've got 115 squared And then we've got 235 squared. And then 247 squared, and so on. You get the idea. Now, typically, I would write the sum of the x's right below this and the sum of the x's squared right below this, but I'm actually at the bottom of my sheet of paper. So I'm going to find the sum of the x's squared, or I'm going to list the sum of the x's and the sum of the x's squared over here. So we're just going to add up everything in this column. This is a good thing. If you're doing this by hand, this is a good thing to do with a partner. Just for both of you to do the same thing and see if you get the same answer. So we get 1331, or 1,331 for the sum of the x's. And the sum of the x's squared is this. Now, if you do this with a partner, you can check each other's work. Most of the time, if you're doing this by hand, the error is not an error in understanding. Typically, the error is in data entry, like entering these numbers into your calculator correctly. Sometimes it's an error in misunderstanding or in understanding the order of operations with the parentheses, but for the most part, it's just a matter of typing it in correctly. So I've got the sum of the x's squared is 245,073. Okay, and then the sample size is the number of values I have on this list. So there's 1, 2, 3, 4, 5, 6, 7, 8. So n equals 8. So we're just going to substitute all of those guys into this formula here. So I've got the square root of 8 times the sum of the x's squared. Which I definitely did not leave enough space there. This is 245,073. And that does not need to be there. Minus the sum of the x's squared, and the sum of the x's is 1,331. And then we're taking all of that and dividing by the sample size times 1 less than the sample size. So this is easy breezy. Now you just have to enter it into your calculator correctly. And what I recommend is doing this numerator first. So I'll do 8 times 245,073 minus 1,331 squared, and then I hit enter. So that's my numerator. And then I'm dividing by 8 times 7. You can just type in 8 times 7, or you can just say answer divided by 56. That'll work as well. Hit equals. It's giving me an exact answer. Then I just hit the square root button on my calculator. Square root of the answer. I've got an answer button down here. The square root of the answer is the sample standard deviation, which is this. Approximately 58.098. And let's see what the computer wants. Let's see what MyLab Statistics wants as far as our rounding is concerned. So it says round to 1 decimal place is needed. So I will round this to 58.1. Now the units for the sample standard deviation are the same as the units of the actual data. And so these are prices in dollars for one night at different hotels in the region. So the answer is $58.1. Let's check our answer. Okay, now before we go on to the next piece, I want to show you that you can get the exact same answer doing this calculation in Excel, and it's a little bit faster. It's also nice because you don't have to worry as much about the data entry and the arithmetic. As long as you enter your original data correctly, you're good to go. So I'm going to do that now. If I want this data set and I want to download it into Excel, I go over here, see that little icon, open in Excel. Say yes, please open it in Excel. Okay, I'm going to share my screen again. Okay, so here's our data in Excel. And we had n equals 8, and I've got 8 entries right here. Those were all my x values. Remember, for our formula, we also needed the x values squared. I'm going to use my calculator as a paperweight. And I'll show you my face. Hi. So I've got my x's over here, and in the second column, I want the x's squared. So I'm going to hit equals while I'm in that second column, and then I select the cell that's in a cell in Excel that I'm interested in, and then I just hit caret. That's above the 6, and then I put, you know, a sub or a1 caret 2 means a sub 1 squared or a1 squared, and that gives me that 13,225 that I got when I did 115 squared by hand. So this is really cool. In Excel, if you just grab that corner and drag and drop, it's going to square this one and square this one and square this one and square this one. And if I look at my list over here, I can compare and see that these are the x's. These are the x's squared. They're the same ones that I got with my calculator. So that was much faster. And then remember, we needed the sum of the x's and the sum of the x's squared. So I'm just highlighting this in a different color just to keep track. So I will put the sum of these values here. That's the sum of the x's. So I type equals sum, open parentheses. I select that cell, then drag and drop, close parentheses, and then you've got the sum of the x's. We want to do the same thing for the sum of the x's squared. So sum equals, or excuse me, equals sum, open parentheses. Select the cells you're interested in, drag and drop, close parentheses, and it looks like I got exactly the same values for the sum of the x's and the sum of the x's squared that I calculated by hand. That's a very good sign. And then remember how we calculate that sample standard deviation. It was n, and I will put that in a cell down here. And that's the sample size, so I can say equals count these. Now we already know that n equals 8, but it will count those for us if we use this count function in Excel. And now we say, okay, how do I find the sample standard deviation? Well, I can hit equals, and then I want the sample size times the sum of the x's squared minus the sum of the x's squared. So I hit caret 2. That's my numerator. And then my denominator is my count times the count minus 1. Oh, it didn't like that. So we'll just say this equals 8 times 8 minus 1, which we know to be 7. Okay, and then the sample standard deviation is this divided by this, and then you take the square root. The function in Excel that you need for the square root is SQRT. So it's the square root of, open parentheses, this cell divided by this cell, close parentheses. And we get exactly the same answer that we got for the sample standard deviation on paper. Now, Excel also has built-in functions for sample standard deviation. So see, this one says stdev.s. I believe that's S right there stands for sample standard deviation. I'm not 100% sure, but let's check. Let's do that. and select these cells and see if it gives us the same answer. Yep, that's the one we want. STDEV, that's standard deviation, .S is sample standard deviation, which has a slightly different formula than the population standard deviation. And we use that and we get exactly the same answer. So you can use the formula that I gave you and you can check it out in Excel and make sure you get exactly the same answer. Or you can use Excel's formula, or Excel's standard deviation function, and it's going to give you exactly the same thing. So let's go back to the homework now. Okay, now it asks for the variance of the sample data. You just take the sample standard deviation and you square it. So I'll show you my paper again. So if that is the approximation of the sample standard deviation, actually I think I'm going to use a new sheet of paper now. The sample variance is that sample standard deviation squared. So you could have just written down the value that you got before you took the square root of everything. Or you can just take this one and square it, and it's going to give you the same value that you got under that square root in the first place. So we have the square root, oops. I actually don't need the square root here. We're just going to take the sample standard deviation, which is that 58.098 approximately, and then we're going to square it. And we get 3,375.41. Approximately. Now these were dollars. And when you take dollars and you square them, you get dollars squared, which is a little unusual, which is why we don't really talk about variance much. We usually prefer sample standard deviation because it's in the same units as the actual values on our list. So this is our answer, but it may not be what my lab statistics wants. So let's go back to that screen. Make sure we give them what they want. Okay, they say round to 1 decimal place is needed. So we've got 3,375.4, and that's dollars squared. Okay, great. And the next thing asks us, the next part of the question says, how useful are the measures of variation for someone searching for a room? And then here are the possibilities. It says the measures of variation are very useful because a person does not want to buy a room where the variation is too high. Okay, so they're saying that if the price varies a lot in town, you don't want to buy a room in town, I guess. That doesn't make sense to me. So I don't think it's A. Let's look at B. The measures of variation are not very useful because when searching for a room, low prices, location, and good accommodations are far more important than the amount of variation in the area. I think that that's true. That's probably it. But let's look at the other ones just in case. The measures of variation are very useful because a person does not want to buy a room where variation is too low. So when all of the prices are exactly the same, you might not want to get a room. I don't think that matters. I think you're really looking for a room in a certain location. So no, that's not it. And then the last one says the measures of variation are not very useful because the values are nominal data that do not measure or count anything, and the resulting statistics are meaningless. No, we are definitely measuring how much it costs to rent a hotel room for a night. So no, it's not nominal data. That is a measure. That price is definitely a measure. So it's not D. I think the answer must be B. The measures of variation are not very useful because when you're searching for a room, you want to get a low price. You want that room to be in the right town. Maybe you're interested in visiting a particular attraction, a particular museum or something like that. You want it to be in the right location, and you want it to be like nice, clean, good accommodations. So I think B is our answer. And that's it. So now you know how to calculate standard deviation both by hand on paper and with Excel.